Okay, guys, so for this section, we're actually looking at how to factor using the GCF method. The key and most important thing that you need to know is that we will always begin every problem for factoring looking for a GCF. And there's a couple of indicators that you need to know that will help this process along. The first thing that you need to know is that we're looking for the largest factor or the largest number that divides evenly into all of the terms. Largest number that divides evenly through all the terms. That takes care of the numerical part. But then the key thing, and I don't know if you've ever noticed, you want to look for variables. Like every term has to have a variable. So if we're trying to see if A is a common factor, every term has to have that variable. But then for the GCF, you pick the lowest exponent. Or the smallest exponent. And that's going to be part of your GCF. Then, after you find the biggest number that divides evenly through all the terms and the lowest exponent that all of the terms have, the last piece is that your GCF is going to go on the outside of one set of parentheses, and everything on the inside of the parentheses is going to be what is left over after you divide each term by the GCF. So the GCF is going to be a part of it, but all this stuff that's left on the inside of this one set of parentheses is going to be what you do after you divide each term by the GCF. That's what goes in here. Okay, let's get started on some practice problems so you can see what I'm talking about. Here's an example of a factoring question, and most people would start with trying to factor this trinomial, but this is an example of why we don't want to do that. We want to start with GCF. So what you should notice is that when I'm looking at the terms in each of these, or the number part in each of these terms, you're going to recognize that 3 goes into all of them. And GCF makes it so much easier to factor completely that we want to make sure that we GCF first. Also notice that not every term has an X variable. So what that means is that you can't use X as a GCF because the 27 doesn't have one. So the only thing that we can do is take out a GCF of 3. 3 is the common factor. X is not because 27 doesn't have one to give. Then we put our parentheses in place. On the inside of the parentheses, we're going to take 6x squared and divide by 3. So 6x squared divided by 3 is going to give you 2x squared. 9x divided by 3 gives you 3x. And 27 divided by 3 gives you 9. This gives you a more manageable quadratic to factor as a trinomial, and it makes it so much easier to do that. Get ready for the second problem. In this example, what you should notice is that we have all of our numerical parts, our constants, all are factors of 5. And that each of these terms has an X. So what we're going to do is we're going to take a GCF of 5 out. And when I look at this, I have an x to the third, an x squared, and a regular old x. And we want the lowest exponent. So we are just going to take out the lowest one, which is x. one set of parentheses, and now we're dividing. 5 divided by 5 becomes 1, and x to the third divided by x, one of the x's cancel, and you're left with x squared. Plus sign. 30 divided by 5 is 6. X squared divided by x means I'm taking one of them out, so I'm going to have 1x left. Minus sign. 15 divided by 5 is 3, and x divided by x cancels, and there's none left to give, and this is the quadratic that's left. Next example. Here we have a 14, a 7, and a 35. Because all of these have a factor of 7, that's going to be my GCF. 7 is the biggest number that goes into all of those. Do each of them have an x term? Yes. What's the lowest exponent x that's available? Just a regular old x. So that's going to be my GCF. One set of parentheses, and we divide the coefficients. So 14 divided by 7 is 2, and we're going to subtract off the exponents. So we got x to the third divided by x. I'm going to subtract that off, and that gives me x squared left. Then I have -7 divided by 7 is -1. X squared over x. Subtract that x off, and you're left with 1x left. -35 divided by 7 is -5. And x, subtract that x because x divided by x cancels. You're left with that. For example 4, I've got 6a to the third minus 18ab. It's important for us to look at this one because it looks like it could be a difference of two perfect squares. The only problem is there's just a difference. 6 isn't a perfect square, 18 is not a perfect square, and that's an odd number. So the only thing we can do if we could factor this binomial is to do a GCF. Now our GCF is what's the biggest number that divides into 6 and also 18? If you're thinking 6, you're correct. And as far as the variables go, if we've got a to the third and we've got b, is there any of them that have all a's? Are there any of them that have all b's? No. So that means that the only GCF we have here is 6. And when we do 6 divided by 6, we get 1, and a to the third comes down. That doesn't change because it's not a GCF piece. Minus sign. 18 divided by 6 is 3, and the b comes down. So this is an example of what happens when you have no variable GCFs. Example 5 has 3 as a GCF because 3 is the common factor with the numbers. But let's take a look at the variables. Do each term have an a? Yes. What's the lowest exponent a? Oh, just a regular a. So that's our GCF for a. Do both terms have a b? Yes. What's the lowest GCF, or what's the lowest exponent that I can pull out for a GCF for the b's? B squared. So our GCF for this question is 3a b squared. Now what we need to do is we need to divide the coefficients. So 3 divided by 3 becomes 1. We're going to subtract off those exponents. So a squared over a means I still have an a left over. B squared over b squared cancels. The only thing left when I divide this first term by the GCF is a. Plus sign. 15 divided by 3 is 5. The a divided by a cancels. And b cubed over b squared, we still need 1b left. So my final answer is 3ab squared times the quantity a plus 5b. All right, I see. It's a little unconventional turning my paper sideways, but I just ran out of space. I wanted to save paper. But number 6 is pretty large, so you want to make sure that you have it all down so that we can look at it. Number 6 says 8a to the fourth b to the fourth minus 28a to the third b to the third plus 4a squared b squared. And we're looking for a GCF. So we've got 8, 28, and 4. What's the biggest number that divides into all three of these constants? If you're thinking 4, you're correct. So 4 goes into 8, 4 goes into 28, and 4 goes into 4 itself. So 4 is our GCF for the numbers. Now I'm looking for the smallest exponent, as long as everybody has one. Does everyone have an A? Yes. Smallest exponent is A squared. Does everybody have a B? Yes. So the smallest exponent is B squared. There's my GCF. And we're going to have one big parenthesis to put all the leftovers in after we divide. 8 divided by 4 is 2. 8 to the 4th over A squared is A squared. B to the 4th over B squared is B squared. There's our first term. Ooh, I better write smaller. Minus sign. 28 divided by 4 is 7. A cubed over A squared is A, and B cubed over B squared is B. Last term. 4 divided by 4 is 1. A squared over A squared is 1, and B squared over B squared is 1. So you have to have a placeholder of 1 there, because this term divided by itself is the whole number 1. Don't forget that that means something. You need to have that term there. If you're confused and want to make sure that you did it right, you can distribute this back out, and you should get the answer that you started with. Contact your teacher with questions.